Who jumps out of perfectly good airplanes in the name of science? Mr. C.
Happy Thursday to you all, and yes, if the question is, can I see the weekend from here? Not only can I see the weekend, I can see the 3-day weekend from here. Anyway, journal's out. You're going to use your journal. You're going to write in little tips on the test in just a little bit that you will have tomorrow. Now, one of my topics today is the weather, and I got to tell you, I'm bummed about the cloud cover. And I already told you that meteorologists blew it. They thought it was going to be sunny and warmer, and it was going to be clear at night, and we'd get a really good opportunity to look at Orion. Didn't happen, and I don't think it's going to happen tonight. Maybe Friday night. So just take a look, but I'm going to have you hold off on turning in that observation until probably Monday. I'm going to go over the other stars in Orion and some key things about them, so that when you look at Orion, you'll have more knowledge and it will be more interesting to you because you know more about the stars in Orion. And of course, looking at the rainbow star, Sirius. So Monday, I'll have time to go over that, so we'll hold off and wait. Just another weather note, just really quick. We're moving into a little bit more of a weather pattern, I think, over the weekend, maybe Sunday. There is some increased chance for rain. So I'm just giving you a heads up on that. And let's keep praying that we get a lower jet stream to give us another storm or two or three or four like we had 3 weeks ago. That was a doozy. So we need a few more doozy storms like that. So anyway, the bat video that you watched, I want to make a few points about it. First of all, the scientist, Spallanzani, the Italian scientist, who did a lot of the early research on bats. Did you notice he was a true scientist? Now, they portrayed him as being a little weird and kind of crazy. He wasn't. He was not. So, now he was a Catholic priest at the same time. A little bit like the founder of genetics. Same kind of deal. A Catholic priest, and the Catholic Church then had a lot more say in science. Now, a couple of comments just really quick. Spallanzani was worried that he'd get in trouble with the Catholic Church. The Bible didn't say anything horrible about bats, but the Catholic Church did. So he was worried that if he talked about his research on bats, he'd get excommunicated, kicked out of the church, and who knows. So he was worried. So Galileo put up with the same kinds of issues, or somewhat. So it's because the Catholic Church was not just a religion, it was also the government. So that's why. So anyway, Galileo in Italy, Spallanzani in Italy. Galileo preceded Spallanzani. Spallanzani was born just after the turn of the 18th century, so 1706 or something like that. So anyway, Spallanzani was fascinated with bats, and hence all of his study. Did you notice he was a true scientist? He worked with variables and controlling the variables. He had a hypothesis. He came up with hypotheses. He hypothesized that if the bats couldn't somehow make sounds with their mouth, he closed their mouths off, they couldn't fly then. So he reasoned that that was really important, but he didn't know exactly what it was that enabled them to see at night. So anyway, we've discovered these divine designs about bats. They get lift at low speeds, way better than birds. It's the way God designed them. They have tiny muscles to control their wings, the wing shape, which gives them more lift. They can actually bend their bones. Their bones are incredibly light. Remember that current scientist at Brown University who weighed that one bone, and she said it was 8 thousandths of a gram. It was so light, and the bones actually are flexible and bend. It's a God thing. By the way, 8 thousandths of a gram, that would be thousandths. What prefix in front of gram? Milli. So 8 milligrams. So anyway, their equipment and their instincts, even though that scientist at Brown is an evolutionary scientist. So she's got a deal in her mind with how in the world did they get these incredible designs, and then how do they know how to use them? There's no way it happened by itself. She's just drinking the evolutionary Kool-Aid. The evidence is poor for evolution. It's just really poor. But when you're in the sciences these days, to be politically correct, you don't dare say it was created. Or you could lose your job. You could lose your university job. So anyway, so all of that about the bats, pretty cool. Now, 7th grade, I want to help you with your test. I have put right here in, let's see if I can get this. This is homework notes for Thursday of this week in RenWeb. I have listed all the topics. I say tomorrow's test topics, and then here they are. Many of these are direct questions and or answers on the test. So it would behoove I say, it would behoove you to really pay attention right now, like laser lock right now with your journal out and ready to write a few little notes and tips. Every Wednesday or Thursday, I'm going to put up the test topics if there's a test that Friday. So here it is. You can look at it yourself later. This is Thursday night's homework notes in RenWeb. Okay, here they are really quick. So I'm doing a quick review with you. The test topics include the metric system and why it's so popular, you already know. Metric system prefixes and matching amounts. That's the King Henry. You've got to know it. King Kilo 1000, Henry Hecto 100, and so on. Make sure you know it. You're going to have to know it or it's going to cost you. Make sure you know 1 meter is about 3 inches longer than 1 yard. Make sure you know that a quarter of a sheet, 1/4 of a sheet of notebook paper equals 1 gram. And make sure you know that 1 liter is equal to about 1 quart in our English system. Celsius temperatures, freezing point, 0 C, boiling point, 100 C, of course. A measurement word everyone knows and uses. Standard units, like foot or pound or gram or liter. I don't want a specific standard unit. I just want standard unit. A measurement word everyone knows and uses. Hey, how many times have I done that now? Too many, Mr. C. I'm getting tired of hearing standard unit. A measurement word everyone knows and uses. So I bet I repeated it a dozen times. If you miss it now, I'm going to roll my eyes. I should. I mean, you should know it. You should review it. So what else do I have here? The definition. What do we call the amount of space an object takes up or how much a container holds? Volume, that would be volume. And then a definition of matter, anything that has mass and takes up space, those two things. The small amounts of matter, tiny particles, are called atoms. Originally, they were supposed to be the smallest you can get. They weren't. Why not? Because atoms have in their nucleus in the center, what do they have? Positively charged protons and neutrons. And orbiting the atom really fast, what do you have? Negatively charged electrons. Electrons with a negative charge. Protons with a positive charge in the nucleus. And then neutrons. No electrical charge. All in the nucleus. Okay? Tiny particles. And then there are much smaller particles than those. Gluons and leptons. And there's a number of ons, O-N-S. So anyway, what else? Kinds of matter. Solid, atoms are really packed tight. Liquids, atoms roll over each other. You can pour them. Gases, loose, free, floating everywhere. And fill up any container they're in. Gases on the sun or other stars. The matter is heated up so much that it just flies around, and the hydrogen atoms fuse together. Fusion. Hydrogen, fusion. What does it produce? Helium, He. And what else? Heat and light. Heat, light, and helium produced in the fusion process. I'm going to ask you all of that. I'm telling you. I'm going to ask you. And then, of course, probably a bonus will be the Beck, B-E-C, Bose-Einstein condensate, which only occurs at near absolute zero, which is minus 460 degrees Fahrenheit. Absolute zero. I'm probably going to ask you absolute zero. If I say to you minus 460 degrees Fahrenheit or almost, what do we call that? Absolute zero. It's where there's no atomic movement, no vibration of the atoms. It's so cold. So anyway, absolute zero. So you've got solids, liquids, gases, and all of that. The sun is mainly made of 75%, approximately 73 really. H for hydrogen. I'm going to ask you for these elements and also their symbols. H for hydrogen. And then about 25% He for helium. H for hydrogen, He, helium. The sun is made of that. The fusion process I've already gone over. About how many different kinds of atoms are they? We call them elements. About how many? About 100 plus. About 100 plus. And what do we call the chart or table that they're listed in? The PTE. What does that stand for? Say it out loud. P, periodic. T, table. E, elements. Periodic table of the elements. So there it is. And the element names and symbols you've got to know. We have discovered that Earth's outer core and inner core is mainly made of Fe, which stands for iron. You've got to know it. Fe, iron. So, and then let's see, what else do you have there? You've got to know H for hydrogen, He for helium, N for nitrogen. The two major gases in our atmosphere. Nitrogen, about 78%, and O2 for oxygen. Nitrogen N, O2 for oxygen. And then I think I mentioned C, our tissues, the tissues of living things, are made of C for carbon. You should have highlighted all of these. C for carbon, H for hydrogen, He for helium, Fe, iron, and then N for nitrogen, O2 for oxygen. So all of those. Then you've got to know what holds atoms together. There are like 4 forces, but I'm going to have you know what 3 of them are. Gravity, but it's really weak. Gravity's not really involved much in the story of holding atoms together. So you've got that. Then you've got the rule that opposite charges repel. So electron, I just really messed up, my bad. Opposite charges like electrons and protons attract. Say that to yourself 3 times. Opposites attract. So electrons are attracted by protons in the nucleus, so they hold together. It doesn't actually get closer, but it continues to be able to orbit like we do around the sun. So opposite electrical charges, positive and negative, attract. Opposites attract. So, and then what's the third glue that holds atoms together? To me, it's one of the really coolest. It's all designed by God. Matter would fly apart. Atoms would fly apart without these design principles at work. So what is the other one? Well, in the nucleus, what do you have? Positive protons. If opposites attract, electrons, negatively electrically charged, and positive protons, opposites attract. What do like electrical charges do? They repel. They push each other away. Repel. So the same electrical charge, you've got protons side by side in the nucleus. They should push apart and the atom should blow up. Why doesn't it happen? It's called the strong nuclear force that holds the nucleus together in an atom. It holds matter together. Are you made of atoms that have protons in their nuclei? You bet. Wouldn't be good for us to fly apart, explode kind of. I'm not interested in that today. How about you? So, what did God do? He knew about the same electrical charges because he created matter with electrical charges. He knew that same electrical charges plus for neutrons, they'd attract each other with that special force, the strong nuclear force, holding the protons together. So he designed them that way, with opposite charges attracting, and like charges should repel, but they don't because of the strong nuclear force. So the strong force also, it is called strong force. Anyway, holds protons together in the nucleus. Let's see what else. Earth's 4 layers, the relatively thin crust, it's solid, and then the mantle, it's soft solid because it's so hot. It gets hotter and denser, more pressure, the farther down you go into the earth. Hotter. More and more pressure. Those two things, the deeper you go into the earth. Hotter. More and more pressure. The hotter, the further you go. Hotter, more pressure. So, crust, solid. The mantle is soft solid. The outer core is so hot it melts, liquid iron. And then the inner core is solid, but it's even hotter. About 10,000 degrees Fahrenheit, about the same temperature on the sun. Isn't that amazing? Did you hear what I said? If I said to you, the inner core of the earth is about the same temperature as, and it's kind of a shock, as the surface of the sun. Wow. Say that to yourself so you remember it. Are you jotting it down in your journal? The sun's surface, 10,000 degrees Fahrenheit approximately, same temperature as the inner core of the earth, about 10,000 degrees. Wow. Okay? And it's solid in the inner core because of the great amount of pressure. Hotter, more and more pressure the further you go into the earth. And I think I've pretty much covered everything on the homework page. It's your job to review it, to look it over. So I didn't cover every specific detail on the topic on the test, but most of it. I'd say 95% plus right there on the homework notes. So it's up to you. Have a look. Triple R it. Triple R really good. So the test tomorrow is on the metric system, matter, and then the earth, layers of the earth and what they're like. Solid, liquid, gas, what are they like? What are they made of? Mainly, what's the earth mainly made of inside? Iron, Fe, iron. Okay, I think I've gone over it all. My daughter Laura is popping in to really help you out. She's going to drill down deeper into some specific tips, things you can do to develop different aspects of your superpower. Remember, your superpower is everything about you that God designed. It's how you look, your physical appearance. So it's your personality that God gave you and that you're developing. It is the purpose that he gave you because of your GoTappy package. GOTAPPI. Gifts, opportunities, talents, abilities, physical appearance, personality, and a great purpose. And for one of them is made in God's image. part of your superpower. So I'm going to turn it over to Laura and write down a tip or two, write down a couple of tips that she's going to tell you, specific tips. Okay, here she comes.
Hi, this is Your Magnificent Brain, Learning with Laura. And I wanted to do kind of a part 3 of your superpower. I know last time we talked about some of the things that we can do to improve and invest our time to kind of invest and develop and improve in the different areas that we're interested in. But I wanted to go back in and really talk about why we use that term leveling up. And this was very purposeful. My dad and I had a conversation about how to really show and really discuss even the process of increasing your understanding, increasing your levels of ability. And the reason why we chose leveling up, and it's very much a video game metaphor of allowing your experience, the time you put into something, to really help you reach the next level of understanding, the next level of skill, the next level of improvement. So it's really purposeful. As we talked about last week as well, or the last time I spoke with you, I think it's 2 weeks ago now, we talked about you are constantly in a state of transformation. You're constantly changing. And that's great, because it means that what level you were at yesterday, if you work at it today, if you work at it tomorrow, you'll improve over time in whatever area it is. Whether you have natural ability, whether you have to work extra hard at it, whether you have to kind of cultivate and really figure out how you even learn best in something, you will improve. I've heard a lot of things recently about people talking about how to gain a level of expertise in something, and you'll hear numbers of hours. You'll hear, oh, it takes 10,000 hours to become an expert at something, or it takes 6 years of dedicated time and effort to become an expert. And what I'd say is all those numbers are kind of arbitrary. Really, it takes the amount of time that it takes for you to get really good at something. And even better, in terms of a way of looking at it, is if you work at it today, you will improve. If you work at it over time, if you work at it consistently, you will continue to improve each and every time you work at it. And I think there's something really comforting about knowing that each time you work on something, you're taking steps forward. It really doesn't matter. The ultimate goal isn't necessarily getting those 10,000 hours or those 6 years, whatever it takes to become really good at something. All of that almost is besides the point. If you want to work at something, just work at it. Invest in it. Take the time, effort, energy to continue to get better, to continue to invest your time in it, and that leveling up will happen. So I also wanted to talk about the subject of grit, the idea of grit. There's a lot of research studies out there right now that look into performance, basically how individuals perform in any type of performance situation. They found that people do better in those situations, regardless of their actual talent, ability in a given area. They do better when they have high levels of passion for what it is that they're doing, so investment from an emotional standpoint, and also high level of perseverance or stick-to-itiveness. So basically, what this research is showing that how we perform, how we actually do in different situations, some of that we own by our level of perseverance, our level of interest in what it is we're doing, and by actually digging in and finding grit, we can improve our performance. And for me, that was very encouraging because it meant that natural talent, natural ability can only take you so far. And by choosing where you invest your time, by choosing the things that you want to have grit with, that you want to be invested in, that you want to actually persevere in, by choosing and actively doing it, you will get better. You will be able to basically perform at a level similar or even potentially better than the people that it comes naturally to. We talked 2 weeks ago about several things you can do. Basically, I gave you 5 different things that you can do to work on getting better at something. And what I wanted to revisit with them is giving additional ideas of what you can do to basically just continue to improve, use that grit to improve your performance over time, to level up. And the first one we had talked about was finding motivation. And we had talked about finding your why and reminding yourself of your why. And as I was thinking about it over the last 2 weeks, I was considering in what ways I remind myself of why I'm doing what it is I'm doing. And what I found is having like a note board somewhere where you put a little sticky note that reminds yourself, work on this, work on your writing, or work on your, if you want to play basketball, work on shooting hoops, work on fundamentals. If you want to work on learning a given skill, a language, putting something up there that reminds you to do your vocabulary. Things that will remind you and help motivate you. That every time you see it, you're reminded of why it is you're doing something. And words, especially your own words being reflected back to you, they have a lot of power. Measuring or tracking your progress. And what I found with measuring and tracking my progress, one, making actual goals that can be met, making sure that they're realistic. So if you're wanting to go from not running at all to running a marathon, making sure that you're looking at it, okay, I'm going to go running for a mile 2 times a week, and then slowly upping that over time. But in addition to setting those goals, like I talked about 2 weeks ago, track in a way that you can actually go in and check mark things off, because that feels really satisfying when you see all the number of times that you met your goal. So on a calendar that you look at, or a planner, or even just keeping a little tally of how many times you did this thing. You went for a run even when you were tired. You went out and shot hoops. Any of those things where you can have that tally marker, that check mark that shows that you did a thing, and you can celebrate that you've accomplished that. I talked about learning from experts, and I wanted to revisit that because I know I mentioned YouTube videos, but what I would say is, if you know anyone who has expertise in a given area that you're seeking to aspire to or move into, it doesn't matter how old they are. They could be in the next grade, they could be a friend of yours, they could be someone who's a lot older. Anyone who has more experience than you, listen, mark what it is that they're saying, pay attention to what it is that they're saying, and even potentially write notes, or after the fact, if you don't take notes as you're talking with them, write down what you remember from those interactions. Make sure that you capture those things so that then you can apply them at a later point. And then we talked about practice, practice, practice. Don't just learn about a thing, but take the time to actually take what you've learned and apply it. Again, if you're looking at a sport and you've heard someone talking about that sport, go out and try that thing, whatever it is. If it's a certain way of shooting the basketball, if you're interested in writing and there's a specific way of writing that you've found that you find intriguing, do it. Just try it out. Don't judge yourself for the performance. Just do it, try it, see what happens. And then I talked about taking on challenges and being willing to risk something, being willing to push yourself, even if it's something that's a little bit out of your comfort zone. If it's you're learning how to play the guitar and all of a sudden you have the opportunity to play in front of people, take those opportunities. Try. See what happens. Usually we're nervous and afraid of doing something, and then once we do it, we gain that confidence to keep doing it over time. And I would highly recommend that those opportunities where you can try, where you can do something that's a little outside of your comfort zone, but that's still within your capabilities, take those opportunities, because then you'll have that win underneath your belt. They'll have that situation in which you've tried something, you've seen that you can do something, even if it wasn't perfect. So I hope this is helpful, going this next layer in really working and investing in the things that spark your interest and curiosity, continuing to really emphasize that you listening to yourself, what engages and interests you, and then taking the time that you have to really invest in you and your interests is important, and really over time can be life transforming. I hope you have a great rest of your day, and I will talk to you in another couple weeks.